Assalamualaikum warahmatullahi wabarakatuh, and a very good day to all of you. Welcome again to the Antenna How Does It Work program. Model 2, Antenna Parameters and Applications. Now, what does it mean by antenna parameters? Antenna parameters are used to describe the performance of an antenna. In this video, we are going to learn on some of the antenna parameters that are very important to describe their performance. We are going to look into what is return loss, bandwidth, gain and directivity, and finally, radiation pattern. Return loss is the amount of reflected power at the input relative to the amount of incident power at the input. Refer to the figure. When you try to measure the return loss of your antenna, and a blue line like this appears via an A, it means that your antenna is not radiating at all. When your return loss is equal to 0 dB, it means that your antenna is not radiating and everything is being reflected back. But when you measure your return loss and it gives you a dip like this, it means that your antenna is radiating, and the deepest return loss here at M3, which is equal to 2.47 GHz, this indicates the operating frequency of your antenna. Now, what is meant by bandwidth? Bandwidth is the range of usable frequencies within which the performance of the antenna, with respect to some characteristics, conforms to a specified standard. In this case, we are going to take a bandwidth at minus 10 dB. So if you draw a straight line at minus 10 dB, you will see that your antenna is actually working from M1 to M2. The bandwidth can be the range of frequencies on either side of the center frequency where the antenna characteristics are close to those values which have been obtained at the center frequency. Multiband antenna can be dual band, triple band, quad band, and so on. The bandwidth of an antenna can be defined as the percentage of the frequency difference over the center frequency. This is the formula on how you can calculate your bandwidth. So bandwidth is equal to FH, which is your high frequency, minus FL, which is your lower frequency, divided by the FC, which is the center frequency. So, if you refer back to your previous example, the bandwidth of the antenna would be 2.58 GHz minus 2.38 GHz divided by 2.47 GHz. If your bandwidth results less than 0.1%, this indicates that it is a narrowband antenna. If you have a bandwidth of more than 1%, this indicates your antenna is a wideband antenna. And finally, if you have a bandwidth of more than 10%, this is considered a UWB antenna. Gain and directivity. Antenna gain and directivity describes how much power is transmitted in the direction of peak radiation to that of anisotropic sources. Gain and directivity are usually measured in decibel or dB. Radiation pattern is a mathematical or a graphical representation of the radiation properties of an antenna. This includes amplitude, phase, and polarization as a function of the angular space coordinates. How do we view the radiation pattern? The first way is we can view it in polar pattern. In polar pattern, you are able to see the major lobe of the antenna, which is the main direction of the antenna, followed by the minor lobes, the back lobes, and also the side lobes. You may also observe the first null beam width and also the half power beam width. Next, we can also view the pattern in linear form. In linear pattern, you are able to see the major lobe at the center, followed with the side lobes and back lobes on the left hand and right hand side of the graph. Finally, we may also observe the pattern in 3D form, like this one. There are three types of radiation pattern available. The first one is isotropic. An isotropic radiation pattern is defined as a hypothetical lossless antenna having equal radiation in all directions. Imagine that your antenna is placed in the center here. So if you have an antenna which is isotropic, it means that the antenna is radiating equally at all directions. Next, a directional antenna is one that have the property of radiating or receiving electromagnetic waves more effectively in some directions more than others. If you look into this figure, this antenna is actually radiating more at 0 degrees compared to the other area. Next, we have omnidirectional. An omnidirectional antenna radiates equal radio power in all directions, which is perpendicular to an axis, with power varying with angle to the axis, declining to 0 on the axis, and it looks like a donut shape. Let's move on to antenna applications. For Wi-Fi applications, antennas are placed in computers, mobile devices, and other equipment to interface with Internet. This frequency ranges from 900 MHz, 2.4 GHz, 3.6 GHz, 4.9, 5, 5.9, and 6 GHz. Antennas are also used in military communication on marine ships, tanks, aircraft, and submarine. They are used for jamming, direction finding, radar, and military SATCOM. Antennas are also used for TV broadcasting applications. Some of the examples of TV broadcasting are commercial TVs like RTM, TV3, and Al Hijra. They are also used in astro broadcasting, which have an uplink of 13.75 to 14.5 GHz and a downlink of 10.95 to 12.75 GHz. Next, we have antennas used in FM radio stations. Like one we have here, if you refer to this table here, the frequencies differs from each other at certain locations. Finally, antennas are also used for mobile communications. They have 2G, 3G, 4G, and 5G capabilities, and in the future, 6Gs. For 2G capabilities, we have GSM 900 and also GSM 1800. For 3G capabilities, we have UMTS 900 and UMTS 2100. For 4G capabilities, we have more LTE 700 up until LTE 2600.